Time series analysis is useful for predicting future results for a variable based on past results. In this example, we'll look at a dataset measuring cash flows for a business, and we'll create two different models. In the first, we'll project results based only on the cash and date variables. In the second, we'll also consider the contribution of additional variables to see how these affect the modeling results. First, we need to select the data source for our analysis. For this example, we'll use one of the sample files installed with the application. Next, we'll preview the columns to get a better understanding of the data source. Note that the records are arranged in chronological order and that the cash column is at the right. Here we can see that the values in the cash column stop before those in all of the other columns. For our first model, we'll consider only the date and cash variables to make predictions for the missing values in the cash column. In our second model, we'll also include the other columns to see if they help the model to better predict the missing cash values. Next, we need to provide a data description to correctly identify the characteristics of the data, such as the data type for each column. We can click Analyze to get the application to generate a data description automatically, or we can load a separate description file. Note that you must manually validate the results if you use an automatically generated data description. For this example, we'll load a description file. Now we can see all of the variables from the data source, along with their associated data types. Here we can create filters to restrict the data for analysis. For this example, we will not apply any filters. The time and target variables have been correctly identified by default. At the left is a list of additional variables available for analysis. For our first model, we'll exclude all of these additional variables. Here we can review our modeling parameters. Now we're ready to generate the model. Here we can view a summary of the model output. Note that the horizon-wide MAPE value for the model is .239. This means that the model has a forecasting error of around 24%. Now we'll view the forecasts generated by the model. Here we can see the actual cash values in green against the projected values in blue. The orange blocks identify outliers, where the predicted and actual values differ significantly. At the end of the green line, only predicted values in blue are available. Note that there is a blue triangle area that shows the minimum and maximum error range for the predicted values, and that the range expands over time. Now we'll regenerate the model and include all of the additional variables in our analysis. Now we'll move all of the excluded variables back to the predictable variables kept area to include them in the model. Note that these variables are useful because we have results for them in the period for which we want to predict the missing cash values. Note that the horizon-wide MAPE value for the model is now .129, meaning that the model has a forecasting error of around 13%. This is a big improvement from the first model, which had a forecasting error of around 24%. Now we'll view the forecasts for the updated model. Here we can see that the blue line for the forecasts is much closer to the green line measuring the actual cash values, and that there are fewer outliers. The blue triangle area showing the maximum and minimum projected result ranges is much smaller, indicating that the values can be predicted with greater accuracy. Now we'll save the model. For this example, we'll save the model to the same location as the original data source. Now we need to enter a name for the model. Now we'll apply the model against the same dataset used to generate the model. This will generate an output that contains the values predicted by the model for each record. The dataset we use to create the model is automatically selected as the application dataset. For this example, we'll use the default generation option, predicted value only. This output method will include the date and cash variables from the original dataset along with the predicted cash values. Next, we need to enter a name for the output of the model. Now we'll view the output. Here we can see the date and cash columns from the original data source, along with a KTS1 column that holds the predicted cash values and a KX index column. You now know how to use time series analysis in SAP Predictive Analytics. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.